Good day, stat students. So today we're going to go over section 8.4 and choosing the sample size necessary to create a confidence interval for the population portion P. And so what this is all about is the following, is that often as a statistician, we get asked, how large should our sample size be in order to do a particular procedure? And that's a pretty big deal in a real study, okay? So if you were simply doing some sort of surveying, asking 20 extra people to fill out a survey doesn't cost you hardly any extra money. Okay, just may add some time to what you're doing. Okay, but if you add 20 extra people to a medical research procedure, okay, maybe they're testing out a new medical drug. Okay, that might cost the researchers an extra $2 million to bring in 20 extra people. Okay, and so basically what people are asking, how large of a sample size do I need? Basically what they're asking is how small of a sample size can I get away with in order to do what I wanted to do statistically? That's a pretty big deal in the real world. Okay, and we're just going to give you a taste of what we do in order to figure that out. Okay, and we're just going to go over one scenario only. Okay, so what we're going to do is we're going to try to figure out how large of a sample size is necessary for creating a confidence interval for the population portion P. So let's get this out of the way, okay? In the problems that we have already done in creating a confidence interval with population portion P, we've been telling you what n is, okay? We tell you what n is and you go calculate the confidence interval, right? Well, in the real world, okay, in a real experiment, is anybody going to tell you what simply n is? Okay, and the answer is no. You got to kind of go figure it out. Okay, at least the statistician does. All right, and so this is like taking one giant step back. The giant step back is that we didn't collect any of our data really, and so we have to figure out how large of a sample size in order to do what we want to do. And here, what do we want to do? We want to create a confidence interval for the population portion P. Okay, so hopefully that makes sense. So is there a formula involved? Absolutely. Sorry. Okay, but there is. And so what we're going to do is we're going to start with this. Here's a bit of a reminder. Okay, here is the confidence formula for P. Okay, so remember, this is the point estimate, critical value, okay, standard error. And do you remember when you take the critical value and multiply by the standard error, what it gives you? We call that the margin of error, okay? And so keep that in mind, all right? What we're going to do is we're going to let m to be equal to the margin of error, okay? So that means what we're doing is that we're going to go ahead and set m to be equal to, okay, notice what we did here. We set it equal to that, okay? And what we're simply going to do is this. To figure out the formula necessary to create a confidence interval with the population portion P, all we have to do is now solve for n in this formula. Okay, so what I'm going to do is I'm going to spare you the gory details with regards to the algebra. Okay, and this is what we get. So this formula right here is what you need in order to go ahead and figure out the sample size. Notice n is the sample size. Okay, and so how large of an n do we need in order to create a confidence interval for the population portion P? So what this is telling us is the following, is that if we have an idea of our confidence level like 90% or 95%, remember 90% we would use what, 1.645, and for 95% we would use 1.96, and that's what's basically going to go in here. I shouldn't say that's what's basically going to go, that is what's going to go in there. Okay, and then here is m, right? M squared, right? But m, okay, what is that? That's the desired margin of error that we want. Okay, so basically, if we have an idea of how large of a margin of error that we want, we can go ahead and sort of back into how large of a sample size we need. All right, we'll go over that here in a little bit. So first, what we must decide on is the desired margin of error. Second, we must decide the confidence level used to create the confidence interval, right? Because if we want a 95% confidence interval, we know in our formula that we're going to have to use 1.96 for our critical value, and so on and so forth. Okay. Then 3, how to handle p hat. Okay. Remember, p hat is x over n. All right, but we're trying to figure out what n should be. Okay, so we don't have a value for n, so we got to figure out how to handle p hat in this formula. All right. So how do we do that? Well, let me just read this. It says to do these in order, meaning you start with the first one, and if the first one doesn't apply, you do the second. Okay, and what does this pertain to? How to handle p hat in our formula. Okay, and so let's read this. It says often a preliminary sample is done for a much larger study, and if a preliminary sample was done that calculated p hat, you go ahead and use it. Okay, and that's what happens a lot in a full-blown study. You know, you're doing this big study, and what happens is that often we do a preliminary sample first. Well, if you gone ahead and calculated p hat from that preliminary study, use it. Okay. There's something else that you could do here. You could also use someone else's estimate for p hat from a different study. So if you trust what they did, go ahead and use it. All right. Now, if that doesn't apply, you go to 2. And what does 2 say? It says you simply set p hat equal to 0.5, and that's the most conservative thing that you can do. Okay, and meaning conservative is that that'll basically maximize that part of the formula, and so you would just simply use 0.5 and you move on. Okay, so let's just get into a problem. Suppose a researcher wants to create a 98% confidence interval for the proportion of drivers below the age of 40 that text while driving. The researcher asks the statistician, how many people should she ask if the researcher wants the confidence interval to have a margin of error 1%? So remember that 1%? That's a lot of precision. Okay, so let's see what happens. Okay, so here's our formula. Let's start with p hat. Okay, remember what I said is that if we have a preliminary study that was done, we go ahead and use it, or if we got somebody else's study. Well, did we have that here? If you read through this again, I don't think you have that here. Okay, I don't see any kind of preliminary sample that was done. So what are we going to have to do? We're going to have to set p hat to what? 0.5. Okay, we're going to have to set it to 0.5. Okay, what else? The critical value depends on the confidence level. Since we set it at, since the researcher set it at 98%, what are we going to have to do? We're going to have to set our critical value to 2.33. So we know what that is. Third thing, the desired margin of error. What did the researcher want? She wanted an awful lot of precision, and she wanted the margin of error to be 1%. Now, I'll just warn you of this. Okay, if we're setting the margin of error to 1%, you must change this to 0.01 in the formula. You can't throw in percentages in the formula. You got to change it to a decimal. Okay, make sure you change it over to a decimal. Now I think we have everything. So p hat 0.5, right? Critical value 2.33, margin of error 0.01. Okay, get your calculators out, get a piece of paper and pencil, maybe write the stuff down. Okay, hopefully you've been doing that. Once you got your calculator, come back. All right, so here's the pieces parts again. Okay, let's go ahead and fill it in. So n is equal to 0.5 times 1 minus 0.5. Well, that's 0.5 times 0.5. Please remember to do this. This often is the case, is that people forget to square things here. They know what to fill in, they get the idea what's going on, and they forget to square things. Okay, please don't forget to square things. All right. So when I squared 2.33, I got 5.4289. When I squared 0.01, I got 0.0001. However you want to do this. You want to throw it all in your calculator once, I don't care less. Okay, I just broke it down in little pieces parts. Okay. So once I figured it all out, I got a sample size of 13,572.25. Wow. Somebody see any problems with this? I mean, 13,572.25. Well, let's take this one step at a time. can you sample a quarter of anything? Can you sample 13,572.25? What does sample size always have to be? Sample size always has to be a whole number, okay? Like 100 or 104 or 206. It's got to be a nice whole number. Well, this isn't a nice whole number, right? It's 0.25, okay? So, let me tell you this is that this is the minimum that we need. This value right here, that's the absolute minimum that we need, okay? And so let's see, that's the minimum that we need, but we need a whole number for the sample size. So we got a bit of a problem here. And how are we going to solve it? We're going to round up. Hopefully you kind of thought that one through. Okay, so to solve both of these issues, we're always going to round up to the nearest whole number for n. Okay, and so remember, this was the minimum that we need. Okay, but we need a whole number. So we're not going to just drop this and say 13,572 because that doesn't uh, um, that's not large enough. Remember, this is the minimum that we need, okay? But we need a whole number. So what we're going to do is we're just going to round up. So we're going to go ahead and we're always, doesn't matter what this turns out to be, if we got a decimal here, we're going to go ahead and round up to the nearest whole number. And what is that going to give us? Our final answer is 13,573. Okay, so technically that's our final answer here, all right? But hopefully you have a problem with this, all right? That sounds like a really, really, really big sample size, okay? So why did that happen? Well, one, remember, she didn't have a preliminary study that was done. And so this part of the formula gets maximized uh, when you have to throw in 0.5, all right? Then she had a 98% confidence interval, okay? That's pretty confident. And that makes it the sample size that much larger, okay? And then the third thing is that she wanted a lot of precision, 1%, okay? So let's see how we could change this around, okay? And maybe we can get away with a smaller sample size, all right? So like I said, this seems awfully high, all right? And I just told you why, all those pieces there, okay? So you can read through that, but I just said all those things, okay? Kind of forgot that I had that slide, but it's the same thing what I just said, okay? All right, so let's change things up to lower the sample size because this is way too high. All right, here was the original question. All right, remember we had 98% confidence interval. We had 1% here, and we didn't have any preliminary sample that was done. All right, so here's the modified question. Suppose a researcher wants to create a 95% confidence interval. That's more of a typical confidence level anyways, so let's go ahead and set it to 95% for the proportion of drivers below the age of 40 that text while driving. Okay, and she does a small preliminary sample and finds that 25% text regularly while driving. I don't know if that's the case, okay? But what did we just do? We did a small preliminary sample, okay? And now we have an estimate for p hat, 25%, okay? Or 0.25, because we're going to have to change it over from a percentage over to a decimal in the formula, okay? And we went ahead and changed the margin of error, if you read through that, 3%. So we don't have so much precision here, but it's good enough for what we're trying to do. Okay, she goes, you know what, that's good enough. Okay, so confidence level at 95%, we're going to use 1.96. P hat, we're going to have 0.25, and a margin of error, 0.03. We throw that stuff into the formula, okay, and I broke it down into pieces parts here, okay, and I got 800.33. 800.33, okay. So, is that our final answer? No. Our final answer is not 800.33 because sample size cannot have a decimal to it. It has to be a nice whole number, and this is the absolute minimum that we need. So what are we going to have to do? We're going to have to round up. What are we going to round up to? 801. That's our final answer. Okay, look at the difference there. We didn't even change a whole lot. We went from 98 to 95. We did a little preliminary sample ahead of time, and we loosened up the precision there from 1% to 3%. That's all we did. And look how much of a difference that we had. We got it down to 801 versus the 13,000 something, right? So hopefully that gives you an idea what's going on here. Now, oh, by the way, just to let you know, is that uh, you'll hear this in, say, a political poll. You might say, uh, you might hear something like this: is that in a political poll, we asked 1,000 people, okay, and we asked, who they were going to vote for in a particular presidential election. Well, you know where they got that number from? That 1,000? It comes from this formula right here. Believe it or not, it comes from this formula. And so um, they use zero point 0.5 for p hat. Okay. The critical value is usually set to 1.96. It's usually a 95% confidence interval. And then I think the margin of error is set to like 3.1%. Okay. And I bet you if you put those values into the formula, I bet you're going to get about 1,000 people then. Okay. An N of about 1,000. Okay. And so that's where they get that 1,000 from in order to go ahead and create confidence intervals for the population portion P for a presidential election. Okay, because remember, P would be the percentage of all people that is going to vote for a particular candidate, right? And they want to create a confidence interval for it, okay? Because they're not asking everybody when they do those political polls, okay? And so, anyways, that's where they get the 1,000 from. All right. So thank you for your time, and that ends 8.4.